Good afternoon. Welcome to the openIDL Industry Test Drive. This is lap number 2, the architecture review, where we're going to getting deep into the inner workings of openIDL and the technical stack that brings it all together. My name is Truman Esmond. I'm the Vice President of Solutions and Partnerships at AAIS and also the technical lead for openIDL. And I'm here with Bertrand Portier, the CCO of Insurance for IBM, part of the Global Business Services Unit. This is the second lap, if you want to hit the next slide. This is the second lap in our 3-week industry test drive. And we are, I'll hit the next slide, Bertrand. Great, so this is the second lap, the architecture review you see on that slide there. We've had an initial webinar to kick off the industry test drive last week, and yesterday we did the kickoff call, which you can review and is available as a recorded webinar. If you go to openidl.com or AAIS.com/openidl, there's links to both the recordings and the links to register for the upcoming webinars. With that, kind of where we are in the first of our 3-week industry test drive. Tomorrow we'll be doing a virtually guided node install where we actually getting your hands dirty, standing up here on the openIDL network. Thursday doing the data call experience, actually seeing the data flow through and be delivered. Then we'll actually have Thanksgiving week, so we'll invite everybody to review the materials that have been prepared this far. Continue to sign up for an actual test drive, so you can stand up a node in your own IBM cloud environment. That sign up will continue till just after Thanksgiving week, where we'll also be having post-holiday office hours, Monday through Wednesday, for any support you might require in standing up your own node or any questions you have on the information provided to date. Then we'll take a little break before we do the final playback on Friday, after firing off the data call that will be the example report that we'll do for the industry test drive. So with that, I will hand you over to Bertrand Portier to talk in detail about the openIDL technical architecture. Bertrand.
Thank you, Truman. And then before we dive right into the architecture, just a quick reminder on what is openIDL. And then we'll talk about the data access platform that you see here at the bottom and how the apps, and the data access platform are architected. So a quick reminder, openIDL first and foremost is about its members. So openIDL is a network for the US property and casualty insurance industry. And as Truman explained yesterday, openIDL is open not only to insurance carriers, but also to other members of the insurance industry, reinsurers, third-party providers, technology company, advisory organizations, regulators, etc., etc. And then the members interact with each other via the data access platform, and this is where we use blockchain. So you're going to get to know more about that today. And really, what we are talking about here is to be able to provide access to your own data in the context of a specific application. And you see we have the data platform here, and then on top of it we have applications. The first one of them is regulatory reporting, data call, that Truman demoed yesterday, and we're going to do a live session on that. And we have other ones in the works that are built by the industry and for the industry as part of the industry working groups. So with that said, high-level overview of the architecture to get started. And then what we do after this, we go into details around the data and the data model. And we'll show you the life cycle of the data, how data moves, is transformed, is accessed, etc., etc. But first of all, let's just take a high-level view of openIDL and its architecture. And one way to think about it here is to look at what's at the core of openIDL and what is the glue that allows the different. Let me just go back here. So go here. Sorry, the different members and the different participants to interact. So all of the participants here are connected by a blockchain network and only by a blockchain network. Right, so you will see when we go deeper that the interactions and the data exchanges, the data accesses happen all via that blockchain network. And we have a blockchain network, and what it means is that we have a distributed architecture. We have distributed spheres of control for the different participants. So as an example here on this diagram, you see on the top left is carrier number 1 and their environment. Carrier number 1 is in full control of their single tenant environment here in the blue box. Carrier number 2, again, is in full control of their environment. So they use openIDL components, that are shared across the network, like the data model, like the applications, etc. But the actual implementation of the data store or the application, etc., the blockchain peer is in their control. Right? And then for carriers who are maybe smaller or who do not want to be in charge of their own environments, then openIDL also has a multi-tenant carrier environment. That's the top right green box here. And this is hosted and managed by AAIS today. But you could think of also in the future associations managing that environment for their members, like maybe an association for mutual insurance companies or things like that. Right? And then the bottom right is an environment that is created and used in the context of a specific application. And in our case, it's used in the context of a data call. When state regulators issue a data call, then an advisory organization, AAIS in this case, is going to use that analytics environment to create a report to regulators. And AAIS, like the rest of the members, is connected to the network via blockchain. So that talks a little bit about the distributed aspect and nature of the network in terms of who uses openIDL, because of the first application we are talking about today, where we're talking about regulatory reporting staff and statistical reporting, etc., only because it's the first application. But then you could be thinking about in the future, if we are doing flood modeling, for example, you can think of underwriter using the flood application on top of openIDL. And then what's a little bit unique about openIDL here is that it's really about data. So what we are connecting to are existing data environments, data stores, etc., that have existing policy and claim data from the data owner, the insurance carrier. And then what we do with openIDL, we allow for that data to be transformed into a format that everyone understands, and we give controls to data owners to allow them to provide access to that data in the context of the app. So that's at a high level what this is about, and the distributed controls. You will see more about how we make that a reality when we dive a little bit deeper. One thing to mention as well is that the software components are based on open source software. So I'll show you specifically what the list of software is for openIDL and what we use. But you think of Apache, Hyperledger, and other open source communities and foundations for where the software is coming from. And then very, very important for participants, we know that you cannot just run on any cloud, and sometimes you have to be on-prem, and you're not even allowed to run off-premise. So these boxes, the blue boxes and even the green boxes and purple, can be run on your cloud of choice. So when you onboard openIDL, you can onboard on your cloud of choice. And I will show you how we make this happen, basically on top of an OpenShift-based architecture. So that's a high level. Truman, any comments or other things you wanted to mention at a high level?
That's the core. The key is making sure that the data is protected from the data, is in your control of the data owners. It is an expandable platform that allows us to see trust, to trust all the way to the bottom of the pool. That's really the key. So I'm excited to dig into the different components so that you can see how all those different elements come together. We'll say we do have questions, Q&A open, so please go ahead and ask questions. We'll do our best to moderate those, bring them forward, and then we'll have time at the end for additional questions. And I think we can actually allow voice recording for folks, so there's a little raise your hand feature. So please go ahead and use that, and we'll do our best to get your questions as we go. Thank you very much.
Thank you. So let's just move to the next section, and that's a key differentiator for openIDL. Well, I don't have a pretty slide here, but this is really, really important to a key differentiator to make openIDL real. And that's at the core of openIDL is the harmonized data model. And it's the data model that is the industry standard for how we describe policy claims and policy and claim events that happen, and how we allow participants of openIDL to participate in those ecosystem use cases. So we have a standardized way to represent policy and claim data. We call it the harmonized data model. It's we spent a couple of releases to really make sure that it is stable, and then that the changes that we make to it going forward are going to be non-disruptive, like additive as opposed to removing existing features. And we based it off of the IBM Insurance Information Warehouse, the IIW. So openIDL licensed IIW as a part of it. And if you're a participant and a member of openIDL, so you get to leverage that for your environment, and I'll show you how that happens. It is in JSON format here, that bullet point here, because JSON format is like a blockchain format. So think of it as you're having off-chain data that is ready to be shared via blockchain, and having extracts out of that off-chain data that go into the blockchain, but the data is already in a format that is understood by the rest of the industry. The data is already in a format that is harmonized and unified for the industry. So we started with homeowners, and that's what is implemented today. And for the first application, the first use case, we call that data model HO+, right? HO+, like homeowners plus. And it's plus because it's based off of IIW and the AAIS stat plans and inputs and feedback and validation from early adopters of openIDL. So we work with insurance carriers, like we did, by the way, to create IIW. We have dozens of years of experience with the industry behind IIW. Same here for the HO plus data model. Like from the get-go, we got input from early participants and validation from early participants that the data model is going to be practical and usable for openIDL.
If I could jump in there real quick, Bertrand. The openIDL data model is also very expandable. This is the first part for regulatory reporting that will be there. So it'll be homeowners in this piece is expandable for other standards to be incorporated into openIDL as a multi-model platform as we move forward.
That's really important, right? Because openIDL is not trying to redefine the different building structures. So it's not trying to redefine, standards, zip codes, addresses, all these things like that, right? And also openIDL wants to be able to leverage insights and analytics that will live outside of openIDL. So not only for reference data, like building codes, etc., but also for additional insights, we have an extensible data model, a linkable data model. And you could think of that as the beginning of networks of networks happening, right? Where you can link to other networks and link to other sources of insights from openIDL. And as part of the membership and the governance of openIDL, we have a way for partners and industry participants to get connected and provide that value to the openIDL membership. And what ends up happening with the openIDL data model, we call HO plus for the first instance, is that it is the schema for the database. It is the schema for the database in JSON format, the document store that you are going to have as a participant in your single tenant environment. So that's what it becomes.
And again, the key thing is to understand what that data model was designed for, its purpose. Yeah, it's not just for regulatory reporting specifically. The model is designed to support all the regulatory data that might be required in this highly regulated line of homeowners. And then depending on your need to respond to that as a carrier, you populate that database with the requisite information, and that will meet your regulatory needs as the data calls are fulfilled through openIDL. So now your regulatory reporting can be increasingly automated as it relates to homeowners, and that model will scale as the definition of what's required changes. You know, as more information is required from regulators, or that is needed to operate as an increasingly larger or even more innovative carrier offering homeowners coverages that may interact more with things like cyber or other liabilities.
So here, so the key point about this, right, is that it's a very, very strong foundation. We invested significant efforts into this, right, to make sure that we have a strong core, not only with the blockchain distributed architecture, but also with the actual data model and data schema that we use, and that can be leveraged for and extended for the openIDL applications beyond, you know, the first use case. Okay, so now we're going to go a little bit deeper into the data architecture. So same as before, right? On this picture, you see again blockchain, the openIDL network, and here you start to see a little bit more about what's happening inside, and a little bit more about how you can integrate with openIDL. And we're going to be looking specifically at data, right? We're not going to be looking at applications, etc., but more at data. And I want to describe this at a high level because what we are going to do next is we are going to show you the data flows and the life cycle of the data as it goes through the openIDL network. And what I want to portray here is that I want to show you, as part of your evaluation and your test drive, how your data is going to be secured, how you're going to be in full control of your data, and how data can be verified for its authenticity, and how data users of your data are going to be made accountable for their usage of the data. And this is realized on that data architecture. So again, you see the openIDL network. The white boxes on the left are the existing environments pre-openIDL, right? So you have existing data. Because of openIDL and its type of analytical use cases, most of the time you're going to be connecting to your existing data warehouses, to your existing data stores, etc., that are on-premise or in your analytics cloud. We provide the data transformation and quality capabilities, but eventually we know that you already have standards for ETL, data governance, etc. So we allow you to use your existing processes, methods, and tools, and then connect into openIDL a little bit later if you don't want to use our ETL tools and quality tools. So that's why you have different options here. So on this diagram, you can see that we have a number of single tenant participants as part of the openIDL network. Like we have 3 blue boxes here. So we have 3 insurance carriers that are participating and connected to the IBM, to the openIDL network. And then we have on the bottom left, the multi-tenant environment where we have, again, a number of insurance carriers, as an example, connected to that multi-tenant environment that is managed by AAIS. And then on the right-hand side here, we have the user of the data. So in that case, it's AAIS as the state agent, the advisory organization that is the user of the data that are connected to the network and that have their own analytical environments to create the data core report. So that's what happens, and the data is moving, if you want, more from the left to the right as we go through all of this. Key components to mention here, and tomorrow, or if you listen to the recording as part of the next technical deep dive and the stand-up, the guided onboarded. We're going to do a deep dive on the specific blockchain components like channels, private data collections, etc., that that allow for privacy of data. But just for today, just so you can follow a little bit. So we have channels between one insurance carrier and AAIS, so that no other insurance carriers can see what's happening between that insurance carrier and the stat agent or the advisory organization. So we have privacy of data here, and we have channel. So if we have 3 carriers here, we're going to have 3 channels with AAIS specifically. And then within those channels, we have the concept of a private data collection. Private data collection is a blockchain concept that comes from Hyperledger Fabric, and it's like a site database, right? So again, hashes for what happens on those private data collection go to the chain, but the actual data that is on those private data collection does not get on chain. And we use those because all of the data exchanges, all of the exchanges, consents, etc., happen via the blockchain. So we don't have any interactions out of bound, outside of the blockchain. All of the interactions are going to happen via blockchain. So we have the audit trail, right? And we know exactly what happened. And we have endorsements, we have validations, etc. And we have a full audit trail for all that happens as part of the interactions. So just very quickly, I think what I will do now, if Truman, if you think this is a high-level overview, what I'm going to do now is to walk through the different phases. But first of all, I will summarize the key tenets of the data architecture, and then we move to the different phases of a data core. But Truman, do you want to make any specific comments here?
Yep, no, those are the key elements, the key participants, the key parts of the architecture with the harmonized data store and the interaction patterns. You know, the ability, want to illustrate the ability for flexibility to participate at any size or scale or you know, or frequency. You know, lots of different ways to leverage the platform, from the multi-tenant to the you know, more work being done in a larger enterprise. That's really the key thing there: flexibility and choice.
So at a high level, to summarize what I tried to explain here, so we have a quote standard data model and data schema that everyone understands at the core of openIDL. And what we are doing is we're mapping from your existing formats into that standard data model, into that standard format, so that we can interact and we can transact together as part of this network. That's the first point. And that standard is proven and is built on top of years of experience working with the industry. The second point is that most of the data is off-chain. So when you think about what happens on blockchain network, only a small subset of data, and typically not the actual data, but more like a cryptographic hash of it, goes on-chain. So most of the data here is off-chain, and I will show you how that happens. It's called the harmonized data store, and you get to see more about this as we go through this. And then Truman mentioned the interaction patterns that are used to extract data out of this harmonized data store to go into the blockchain and be shared with others. And then we use blockchain to make sure that we have authentic data. So every time we transform data, we create a hash of that data. That hash goes on chain. So somebody who uses the data down the road can verify its authenticity. So they can hash the data, compare the hash that they are getting with the immutable hash that was stored on the blockchain to make sure the data hasn't been tampered with. We have users of the data made accountable. So if you're a statistical agent creating a report, your usage of the data is going to be recorded. When you got data from specific participants, when you released the data, what you did with it in terms of reports, etc., etc. As well as if you're a participant in a data call, the fact that you lacked the data call, like Truman demoed yesterday, or the fact that you consented to participate in a data call is going to be recorded. And then privacy is critical, right? And built in by design, you have private exchanges of data that two members of the network can provide access to each other's data without anyone else on the network knowing about it. And that's really important because we have all different sizes of companies, insurance companies participating, and we don't want, right, for the bigger companies, right, for others to see that the bigger companies are doing more transactions or anything like that. So we have privacy built in, and I will show you how we implemented it. Practical integration and onboarding. So we'll talk about openIDL in a box, and what that means. It's your way for you to onboard. In my experience with blockchain network, the onboarding and the mapping from your existing format to the network's format, the ability to onboard, exchange certificates, connect to the existing network, etc., can be a challenge. So here we made it very practical based on our blockchain experience and our data experience with other networks. And then number 5, we have innovations related to how we create the environment for using the data, right? So we flipped the traditional idea of a traditional data warehouse to have those analytical environments created only when we need them and only for a specific purpose. For example, in the context of a data core, and they don't just live forever, they're just there to meet a purpose, and after that they are gone.
Right, and that's to help make sure that we're moving away from the traditional model of replicating data everywhere across the network, which of course immediately gets stale, untrusted, and heavier for each participant to produce. We can create these analytics environments that allow trusted access to trusted data without revealing that data or requiring it to be replicated in different environments. That should be far more efficient and deliver value much more quickly as the data is made available to the industry and the constituencies.
So now, in terms of the onboarding, right before we go into the different flows, so I try to zoom into, if you think about one of the participants here in the single tenant environment, let's say it's an insurance carrier with their single tenant environment, look a little bit more into how you would onboard into the openIDL network. And to make this happen, we created an offering, and it's actually an IBM offering that has support, and that is that you can get as part of an IBM services engagement to get you onboarded and to get you up and running with openIDL. And if you think about this, this would be your next step after this evaluation. So if you want to participate, become a member, then on the technical side, then you need to get that environment up and running and connect to the rest of the network. Right, so we created that offering, and in the final playback, we give you all the details about this, including the different options, pricing, etc. But I just need to, at a high level, cover this today to show you that there is a practical way to join the network. And this environment, like I was mentioning, can be deployed on your cloud of choice, including on-premise.
Right. Quick clarification for the test drive. We're deploying to IBM Cloud, but and you'll have a node on the network, but it'll be a demonstration network. So we'll go through all the motions that are very similar to the production connectivity to establishing a node, but it is a demonstration network, obviously with demo data. So it is not a trusted answer, but a trusted network.
And then what you get in that, in that offering in terms of the software and the functions, right? You get the IBM blockchain platform, which gives you Hyperledger Fabric, the blockchain peer, etc. You get the openIDL application, in this case, regulatory reporting, data call application that we will use during the test drive. You get the harmonized data model, and you get the harmonized data store, right, which is called, which is the harmonized data store that shows that is here. on the left, and then all of these transformations, etc. I will talk to you more about what these are and what software we use there, but all of these is included in the box. So again, if we look a little bit into the details of this, so think of openIDL in a box as software, and that's software that can run on top of an existing Red Hat OpenShift environment, right? So that means that at the bottom here, you see that you can deploy this wherever OpenShift is supported, including on your on-prem private cloud, if that's what you want to do. And then the software components, so if we go here from the right to the left, so it's a microservices-based architecture. There is one microservice, one container for blockchain, and that's Hyperledger Fabric. You get your blockchain peer, and here we show a private data collection. You will also have channels going to other participants in the network, etc. So that's the blockchain component here. And then there is the actual application for openIDL. This is think of this as the UI that the business users would use to participate in the data call, as you saw on the demo yesterday. And as well, we have one component here that we call the blockchain transaction manager, which basically writes to the chain anytime there is a significant event that's happening. And we'll show you what that means as we go through the flow. And we also have extraction patterns to extract data from the harmonized data store and go into the blockchain environment. And then we have data transformation here, which is another component from the box, which is really about allowing you to go from data as it is today in your existing environment, maybe data files that you had in object storage, and ingesting those, doing transformations, quality check, etc., and getting that data into the harmonized and Node.js-based, JSON-based structure that is required for the openIDL network. Right? And then here you see the harmonized data store, which is based off of so MongoDB. We use MapReduce on top of it to do dataset extract, and I forgot to mention that we use NiFi, Apache NiFi here to streams to do those data transformations. Okay, so now we can shift gears and go into day in the life and show what happens to the data. So we have 3 phases. The first phase happens on a monthly basis, and this is completely independent of the rest of the network, completely independent of data calls, regulators, and apps, etc. This is about you as the data owner updating your harmonized data store. So that's phase 1. And then phase 2 is what happens when you consent to a data call, when you say that you are participating in a data call. So I'm going to show you what happens and how data is extracted and provided access to in that case, AAIS to create the report. And then phase 3 is when AAIS creates the report for regulators and get data from blockchain to go into the analytics environment and create the report. And this is a picture that we will go back to. I'm not going to describe it in detail now, but this is the end-to-end data flow. So we'll go back to each one of these steps as we go through the 3 phases. Okay, so first phase, on a monthly basis, you have to basically keep your harmonized data store up to date. So what is going to happen is that what you want to have quality data in your harmonized data store that represents critical events related to your policy and claim data for the last month. Right? And what we are doing here, we're updating the harmonized data store with new entries new records that represent what happens in the last month. And to make this happen, right, what we do, and again, we are completely disconnected from the rest of the network, right? So we have an ingestion process where typically for what we are doing here in the first use case, you think of having existing data files that you use, maybe coming from your statistical reporting environment or other environments, and we are going to ingest those data files and make specific transformations, think ETL, and transform that data from the format it is at today into the JSON structure that is required for the harmonized data store. And right before we write to the data store here, we are going to create a hash of the data, which is basically a fingerprint of the data, a one-way cryptographic hash that is going to go into the blockchain ledger, just to make sure that whatever you put in the harmonized data store hasn't been tampered with when somebody wants to use it later. So if we look at this in a little bit more detail, using the other diagram, right, you see a little bit more about what's happening. And here we zoom in and look at what's happening on the top of the diagram, right, where you have existing data files that are coming in, and we are transforming those into a JSON format. And once we have the JSON records here and entries ready to go, we create a cryptographic hash. That hash is what goes into number 8, the blockchain network, and the channel that you have at your peer that you have between you and your statistical agent. And then the actual data itself does not go into blockchain. The actual data goes into your harmonized data store, which is in our case a MongoDB database. Right? And we have specific quality checks and quality rules that are run as well. They are not shown here in detail on this diagram. They are here on number 3, but we have specific rules that we go through, right, to make sure that what goes into the harmonized data store is of quality. So some of these can be done, but some of these corrections, right, can be done automatically, but others are going to require human interaction, right, to fix some of the issues that we have with the existing coming in data sets that are coming into this data flow. So the result of this, we started with data files in your format that only you understand here on the left, and we end up with 2 things. One thing is that we have quality data in the openIDL harmonized data format that resides in the openIDL harmonized data store, which is off-chain in your control. And then secondly, we also have a cryptographic hash to represent that data that is captured on your peer on the blockchain network. Truman, anything to add there? Okay, so that's the first step, phase 1. And here there's a variation I was telling you about where, down the road, right, at the beginning, you're using the existing NiFi streams that we provide, right, for these data flows and ETLs, transformations, etc. Down the road, you would probably migrate to your standard, right, ETL and governance flows, and then you can connect to openIDL at the blockchain transaction manager right before the harmonized data store. The second phase is when you start to interact with the rest of the network, right? And this is when a data call was issued by Regulator, and you know that AAIS is responding and creating a report for that data call, and you consent to participating in the data call. You consent for for specific subset of your data to be accessed in the context of that data call. Right? So what's going to happen is that a specific subset of the data is going to be extracted from your harmonized data store, and travel via the blockchain to get to only to your statistical agents for them to create a report. So at a high level, if you look at the components that we use here, right? So we have data, there is quality data already in the harmonized data store. Sometimes for some of the data calls, we're going to have to load additional data like we did in phase 1, right, to make sure we have enough to respond to the data call. And then once that is done, then we extract the data. And we use interaction patterns that we demoed yesterday, that Truman showed. So you know exactly, both from a technical and a business standpoint, what data sets and what data attributes are going to be extracted from your harmonized data store in the context of that data call.
And increasingly, let me jump in there real quick if I can, Bertrand. So today, data calls are simply, or exactly as Bertrand said, it's an anonymized aggregated subset. So we're actually extracting data from the set. In the future, those extraction patterns and the requests from the regulators will be more in the form of answers to questions. So rather than querying or delivering a data set, we're delivering a trusted answer from trusted data and not moving the data itself. So increasingly protecting the data and delivering those insights, the derived data and the learnings, the value that the regulators in this case are looking for in order to make effective policy or make different decisions.
So if we look at what happens here, thanks, Truman, what happens here, right? So we have a quality data, it's your data, and you're controlling the harmonized data store. You have these interaction patterns that extract data off of the harmonized data store. They are in your control as well, and you know exactly what's happening there. We use MapReduce functions, right, to do those extracts. And then we use the blockchain transaction manager, right, to interact with blockchain. Think of the transaction manager as a component that is like a blockchain client that we use to interact with the blockchain, right? So that's why we have it here. So we want to make sure that when we extract the data, that it hasn't been tampered with, right, from what was created in phase 1. That's one thing we do, and we can use blockchain for. But then what we do, that data here is going to be extracted from the harmonized data store, and is going to go into what we call a private data collection. So you can see here it says AAIS carrier PDC. So if you participate and you consent to a data call, in your environment, you're going to have one private data collection, and it's going to be here. This is a Hyperledger Fabric component, and then AAIS, as the statistical agent or the advisory organization, is going to have as many private data collections as we have participants for the specific data call. So we have 3 insurance companies. AAIS has 3 PDCs here, right? And you can think of a PDC as like a side database, right? So yes, we are using blockchain protocols to transfer data. So there is no out-of-bounds data flows, and everything is tracked via the blockchain. So we use blockchain gossip protocol, peer-to-peer transfers, etc., or gRPC or whatever is used under the cover here to transfer the data. But that data does not go into the actual chain. It does not go into the immutable chain, right? So this is like a side database that uses blockchain protocols to transfer data, but is not stored on the immutable chain, right? So that data, those data sets that were extracted from your harmonized data store are not going to live on chain forever, right? So they are just going to be part of a private data collection, which at some point, can be deleted. So that's what happens, and then as a result of that, you're participating, and others are participating as well, and the advisory organization is collecting all of these data sets from the industry, and those are arriving on their analytics peer as private data collections. And then if we look at the other view of this, if you look at a little bit more details, so if you go back to the end-to-end picture, we are more looking at the bottom left now. We start from the harmonious data store. We do these interaction patterns. We run MapReduce, right, to extract a subset of the data, only what is required for the data call. And then we load that into the blockchain environment, the private data collection, and that using blockchain gossip protocols goes to the statistical agent. And then the last phase, phase 3, is for the advisory organization or the stat agents or whoever is receiving those private data collections to do something with the data. And again, the actions of the data users are going to be recorded on-chain. So we know when they access the data, we know when they created that analytics environment, when they released the report, when they created the data for the report, etc., etc. Right? And so all of these actions are captured on-chain. So what happens here is that these data sets coming from the private data collections are being extracted from the private data collection, and then they go into probably a store, a data store that is part of the analytics environment. Remember that the analytics environment is only used for the purpose of that specific data call, but it's not something that is there forever. And then the organization is going to do the computations, do the analytics, create aggregations, create reports, create graphical and interactive reports, whatever is required. And then when the report is created, what we do as well is that for that data that is in the report, for these aggregations, results, etc., again, we also create a one-way hash of that data, and we put that data on-chain so that when somebody wants to look at the report later on, they can verify its authenticity. Same kind of idea for how we use blockchain for authentic data. So, and the other view of that is pretty simple here. The data has arrived here into the analytics environment. It is there on those private data collections. It is extracted and moved into the analytics environment where it's going to be used to create the report. So at a high level, these are the 3 phases for the data call, going all the way from you making sure that your data is ready before a data call is issued to you consenting to a data call and providing access to your data being used to create a report back to regulators. Truman, before I do the recap, any other points you wanted to mention there?
Yeah, no. So hopefully that by looking at each of the elements in the in the system as well as the phases that are being used, you can see how the role of the data owner, the role of the untrusted third party, in this case played by the regulator, and then the role of the platform, the blockchain network, in this case openIDL and AAIS as the stat agent intermediary for this particular property casualty regulatory reporting channel, work together to create a trusted platform that really doesn't require any more trust than is absolutely necessary, and that trust that's there in our particular case is codified into law. In the future, you could see how the role of data owner, the role of intermediary, or the network facilitator, if you will, the accountable, transparent governance body in the middle, and the potentially untrusted third party could be played by a variety of different networks, and depending on where you sit, you might be a different role in a different transaction. You might be the role of the untrusted third party querying a trusted data owner, or if you're a carrier, you may be the owner of the trusted data that other folks are interested in. So it's hopefully this has provided some details to see where you might sit, the technologies that are there, and then kicking us off into the next steps to get started, where you actually see these in more than a theoretical or a conceptual diagram tomorrow in the Standing Up a Node tour.
So just to recap the high-level points and the critical differentiators for openIDL. right? So we use permissioned blockchain at the core, right? And I want to emphasize on permissions, right? Because we know the identities of the participants, right? You cannot transact anonymously here, right? So you need to sign your transactions. We have certificate exchanges, etc. And you will see what happened there. When we do the stand-up tomorrow, you will see how those happen so that you can connect to the network. So we have permission blockchain at the core, and all of these interactions and data exchanges, etc., happen via blockchain. And blockchain is how you as a participant are connected to the rest of the network, right? And then what you have as part of that, so you have a way to connect to the rest of the network and participate in those ecosystem applications and use cases. And the second point, then you have specific controls. And this is really, really important, right? Because you want to have control over not only what happens to your data, who you share it with, for what purpose, etc. But also, you really want to be able to go and see for these different components here, that it's good to say that you have control, but you also want to be able to own and manage these components that are going to give you controls. So we provide these single tenant environments where you deploy the software components and based on open source technologies, and you see exactly what happens. You see exactly how data is transformed from your existing data files into the openIDL format. You see exactly, and you have full control over your harmonized data store, which is off-chain. You have full control over that data here. You have full control over what is extracted out of these data stores, and you see what these are. And then once you provide access to your data, it's just a small subset, and that data is not on-chain forever. That data is shared via blockchain gossip protocols, but just for the context of that specific use case or data call. So we use the open source technologies, right, for these software components, like I mentioned before, and you can deploy these components on your cloud of choice. And I think this is really different from a lot of other blockchain networks out there, where some of the existing blockchain networks will be more centralized, will be more like a platform that you can access, and the platform then is managed by somebody that you have to trust. So here we have distributed the trust and the control so that you have your own environment as part of the distributed architecture. We'll talk more about this when we go through the final playback, but we have a practical way for you to onboard openIDL quickly. And what we looked at today, we spent most of the time on, was to really go through the life cycle of the data and all of these things that happen that are in your control, and all of the things that we use blockchain for to make sure that we have authentic data, that people are accountable for their actions, and then that we can track and see exactly what happens to your data. So that was a high-level view of the architecture, and actually it's high-level and a little bit deep as well. Now what we want to do is see if we have any questions live, and we have a lot of time to go through this.
Love to make up some questions. We haven't seen any come through the chat yet. On the chat on the left-hand side, if you go ahead and raise your hand, I can actually allow you to speak on the recording. Or if you want to type a question, put it in the chat. We can answer it here. If you haven't, and while we're waiting, we invite you to visit openidl.com, where there's a link to the other upcoming webinars, as well as the recordings of the prior ones, and then any other questions that we have, we'll have links appearing on there for questions as they come up and as they are raised in these and future webinars. So if there are no other questions, do we have any? Going once, going twice, and we can call this a wrap unless there's anything else. Burton, do you have any other final words?
No, no, thank you very much.
All right, well, thank you everybody for joining us, and thank you for folks that are joining us online, viewing this in a recorded fashion. Please make sure to check out the website and reach out to either AAIS, again, this is Truman Desmond, Truman at AAISonline.com, or Bertrand and IBM, Bertrand.Portier at us.ibm.com. And check us out online and follow us on Twitter and LinkedIn. Thank you very much and have a wonderful day.